Okay, so we know about polar coordinates, how they work basically, and how to plot them. But what we don't know how to do at this point is how to convert from polar to rectangular or rectangular to polar. In this video, we're going to talk about how to convert from polar, which is r and theta, to rectangular, which is x and y. So we're going to take our theta coordinates and convert them to x, y coordinates. And it just has like two conversion factors we need. X is equal to r cosine theta, and then y is equal to r sine theta. All right, so if you can't remember these, you can actually derive it. I don't expect you to remember this, but it is a nice trick to know. So let's just draw a basic thing here. We have r here and theta here. So this vertical part is the y coordinate, or y part of the coordinate, and this horizontal part is the x part of the coordinate. So if we consider cosine theta, this is equal to x over r, adjacent over hypotenuse. And if we consider the sine theta, this is y over r, or opposite over hypotenuse. So if we solve each of these out, we get that x is equal to r cosine theta, and we get that by multiplying the r over, and we get that y is equal to r sine theta, and we get that by multiplying the r over. Okay, so let's just do some examples here and dive right in. So the first one I'm going to do is 4 negative 5 pi over 4. And again, this is r and theta. So we're just going to use our conversion factors. X is equal to r cosine theta, and y is equal to r sine theta. So we just fill it in. All right, so what's r? R is 4. Then we have cosine of negative 5 pi over 4. And then we do the same thing for the y. So this is 4 sine negative 5 pi over 4. Now we want the exact coordinates. So we should find this on the unit circle. So if we think about where negative 5 pi over 4 is on the unit circle. So we go 1, 2, 3, 4, 5. It's over here. So we know for that spot, cosine is negative square root 2 over 2. And we know that the sine is positive square root 2 over 2. So when we reduce this and this reduce, giving us a 2 with the negative from here, and the square root 2, and then this and this reduce, giving a 2 and the square root 2. All right, let's do another one. Let's do 2 3 pi over 2. And again, this is r and theta. So we're going to have x equal to r, which is 2, cosine theta. And then y is equal to r, which is 2, sine theta, which is 3 pi over 2. So when we use the unit circle again, we can find this guy. So 1, 2, 3 pi over 2 down here. So this is going to be 2 times 0. And this is going to be 2 times negative 1. Okay? And so we have our coordinate 0, negative 2. Right? And this makes sense. Let's just diagram both of these really quickly to see what's going on. So if we were to diagram this guy, you would sweep out negative 5 pi over 4. So you'd sweep out to over here. And this r is positive, so we're pointing that direction. So here we are. Now if we think about this in terms of the rectangular coordinates, this actually works out exactly right. And the same thing is going to happen here. You sweep out 3 pi over 2, like this. and then you point in this direction. So 2 out here, which lines up exactly with our rectangular coordinates here as well. Okay, let's do one more. This one's a little quirkier, but that's okay. -1, negative pi over 3. So we just use our same conversion factors. X is equal to r, which is -1 cosine theta, and our theta is negative pi over 3. And our y is equal to -1, which is r, times sine of theta, which is also negative pi over 3. Right? So these thetas match. And we just simplify here. Now, where is this guy? So negative pi over 3 should be here. So the x coordinate is 1/2. And, or the cosine is 1/2. And the sine is negative square root 3 over 2. So if we simplify it, you get negative 1/2. And then you get positive square root 3 over 2. All right. Now this one's a little quirky, so I definitely want to diagram this guy. So let's do a diagram of where this point is. Okay. So this point is negative 1/2 and then positive square root 3 over 2. So over here in this quadrant here. This is quadrant 2. All right. And let's just do the polar plot really quick. So you swing down to negative pi over 3, which is like this. And the arrow is pointing this way, but our r is negative, so we point the opposite direction, which is over here. Which is good because that lines up basically with what our diagram of the rectangular coordinates show. Okay, so I think we're good. If I need to do some more examples, we can do those in another video.